capturing carbon dioxide out of the air usually requires massive, expensive machines in large industrial plants. But a UK startup is taking a different approach, developing small modular units that can be deployed anywhere with electricity and water, making carbon removal far more flexible and accessible. Mission Zero Technologies is a UK-based company developing a new approach to direct air capture, removing carbon dioxide directly from the atmosphere. Their system works by pulling in ambient air using fans and passing it over a specially designed sorbent material that selectively captures CO2. The CO₂-laden sorbent is then heated and exposed to a vacuum, releasing the concentrated carbon dioxide where it can be collected for storage or use. Unlike many other DAC methods that require high temperatures and energy-intensive processes, Mission Zero say that they operate at lower temperatures and pressures, making it more energy efficient and cost-effective. Mission Zero's approach stands out for its small-scale modular units designed to function independently rather than relying on massive industrial infrastructure. Their compact design allows for deployment in diverse locations with minimal setup, making carbon capture more adaptable and potentially more affordable. Their first major project is a pilot plant at the University of Sheffield, which has been capturing 50 tonnes of CO2 per year since 2023. They're also working with Deep Sky in Canada, aiming to capture 250 tonnes annually by 2024. So those projects are pretty small scale and they do still have a way to go there. And like other DAC approaches, there are other major challenges to solve. One of the biggest is the question of what to do with captured CO2, which is tricky for all kinds of carbon capture, even very large scale. Typically, DAC projects are either pulling carbon out of the air directly above where they want to store it, like Climeworks facilities in Iceland, or they're planning to build a network of CO2 pipes to large storage facilities, as is proposed in various European initiatives. It's not obvious how a decentralized and portable, implying non-permanent and small scale, DAC could solve the CO2 transport and storage problem economically. Without a clear and cost-effective solution for dealing with the captured carbon, the feasibility of Mission Zero's model remains uncertain. But if they can solve that challenge, Mission Zero's approach could mean that direct air capture doesn't have to be restricted to massive centralized facilities. If they can make carbon capture more accessible and adaptable, they could help make atmospheric CO2 removal a more practical part of tackling climate change. They even raise the possibility of the technology's high energy usage becoming potentially a positive. Perhaps it could be located at wind and solar farms that have higher levels of curtailment and give them something valuable to do with that energy that would otherwise be wasted. But as always, the real challenge is not primarily the technology, it's making it work at scale, at a cost that makes sense, and operating in a way that makes sense too. If we were to power direct air capture facilities only with midday solar power, say from 10 AM to 4 PM, that's just 25% utilization, and it's going to push up the cost of DAC way higher than its already extremely high cost per tonne of captured CO2. Ultimately, whether Mission Zero's model can succeed will depend on whether it can find an economically viable niche, one that justifies its flexibility despite the added costs of decentralized operation.